Welcome to Exploration, entering the world of secondary science. This video marks the beginning of your journey into Grade 9 science. We'll explore the tools, language, and core concepts you need to succeed. We are entering a new stage of science. The shift moves from simple curiosity to deep, rigorous exploration. Science is about understanding not just what we know, but the process of how we know it, turning observations into complex models. The magnifying glass is a symbol of observation. It represents the active process of noticing and identifying patterns, reminding us to pay close attention to details, which is where true scientific discovery begins. The compass symbolizes direction. Exploration needs a path, and the compass helps us ask the right questions and choose appropriate models. It also reminds us that every scientific idea has limits to its application. We use models to manage complexity because the natural world is too detailed to study all at once. Models isolate specific variables for a strategic focus. For example, physics might model a car as a single point, simplifying the problem. The art of ignoring details is a deliberate choice we make when building models. We make strategic assumptions to find clarity. For instance, when studying gravity, we often ignore air resistance first to understand the fundamental laws. Physicist Meghnad Saha demonstrated this by simplifying the stars, treating stellar matter as a hot gas. He ignored complex reactions and focused on temperature, pressure, and ions. This simple model explained the connection between a star's color and its temperature. Consider modeling a cricket shot. We keep essentials like speed, direction, and gravity, while ignoring details like bat brand or grass pattern. As models evolve, we make iterative progress, adding back details like air resistance to improve accuracy. Science relies on precision in its language to avoid confusion. Words like force and reaction have specific scientific meanings. The global standard of shared terms in the SI system allows scientists worldwide to compare results accurately. Mathematics is the language of thinking in science, not a hurdle. Equations are compact, precise statements that explain how physical properties are related. This practical use helps us predict future outcomes, such as trajectories or reaction rates. Scientific symbols provide standardization. For example, F is universally force. There's also history in symbols. C, for the speed of light, comes from the Latin word celeritas. Universal constants, like the speed of light, serve as pillars of modern physics. Standard units are crucial for fairness and trade, ensuring global consistency. The Gimli glider incident, where a plane ran out of fuel because the crew mixed up pounds and kilograms, shows how vital SI units are to avoiding dangerous errors. Laws describe regular patterns in nature, often mathematically, like Newton's laws. Theories are evidence-based explanations of why those patterns occur, like the theory of evolution. Principles are broad, fundamental ideas, such as the conservation of energy. It is important to remember what a scientific theory is not. It is not a guess. It's based on rigorous logic and has survived careful testing. Theories are based on evidence and are ever improving, open to change as new data arrives. The power of science lies in its ability to predict. Anticipation allows us to predict outcomes before an experiment is done. Examples include predicting the trajectory of a ball, estimating chemical reactions, or forecasting breathing changes during exercise. When predictions fail, science is refined. If a prediction doesn't match observation, scientists re-examine models or measurements. Failures are a strength because they allow science to be corrected by nature, emphasizing evidence over opinion. A key thinking skill is scientific estimation. You don't always need exact numbers to see if an answer is reasonable. Estimation builds intuition, helping you detect errors and guiding decision-making about whether a result is plausible or impossible. An example of estimation is calculating how much air you breathe daily. With rough numbers, 20,000 breaths a day and half a liter per breath, the result is around 10,000 liters. You can double-check this by considering how long it would take to blow up that many balloons. Science is interdisciplinary. The natural world isn't neatly divided into physics, chemistry, and biology. These are categories we created. Consider a face mask. Its function involves physics, chemistry, biology, and math, all working together. Science is fundamentally a human activity, driven by habits of mind, like critical evaluation, and values such as curiosity and collaboration. Look through the magnifying glass of evidence and follow the compass of curiosity. Happy exploring!